So I will be talking today about Project Iris, which is designed to enhance the process of cell phenotyping from fluorescence microscopy images. So if you can move on to the next slide. So in preclinical drug research, the candidate compounds are tested on sort of artificial cell cultures. So at the top picture, you can see plates where these artificial cell cultures reside. So what scientists do is they treat those cells with the compounds, candidate compounds, and also they stain specific cell compartments with fluorescent dyes. And the microscope that you can see in the middle, it doesn't look like a school microscope, but it provides the capability of imaging hundreds of such plates in a single session, produces images. You can see an example image of the cell at the bottom left. And what the scientists are interested in is how potent are the compounds that they are testing, whether they do do cause the desirable effects on the cells. So the classical way of approaching the analytic process is quite tedious. It's lengthy. It requires a substantial expertise. And our job was to build a tool that will facilitate that process. So if we can move to the next slide. So we had built an application that it's a web-based application hosted on Microsoft Azure. So behind the scenes, we are utilizing deep neural networks that had been tuned for the cell assays. We allow for both supervised and unsupervised approach, which allows the scientists to both explore some specific hypotheses and also just explore the data to find out what's in there. So this is, as I mentioned, is implemented in Azure. So thanks to its scalability issues, the resources, the computational resources required scale accordingly with the growing number of users. And we have managed to reduce the processing times from several days to a few hours. And it gives us very similar results to what we had from the classical software. We can move on to the next slide. So this is the overview of how the pipeline works. So on the left, so we start with raw images. So each image contains hundreds of cells. We detect those cells using a deep neural network. We cut out the entire cells. And then we perform all of the processing behind the scenes in the back end. And this involves training a convolutional autoencoder to extract the features from the images and clustering the results just to allow the scientists to visually interrogate them. And this is an iterative process because the scientists can adjust the parameters and rerun the analysis until they're satisfied, and then they can produce the report. We can move on to the next one. So we have used the convolutional neural networks that are used in numerous computer vision tasks. So we use them to detect cells, to extract features, and to classify individual cells for the supervised approach. We use some dimensionality reduction combined with hierarchical clustering. So we also implemented active learning, which allows us to train models with relatively few examples, and everything is facilitated by the infrastructure provided by Microsoft Azure. So if we can move to the last slide. So just to summarize, these modern deep learning techniques can often serve as a replacement for classical computer vision pipelines. Despite their sort of intrinsic sophistication, we can make them approachable through easy to use graphical user interfaces. And because this was a bespoke solution, we were able to fine tune the product for the specific organization's needs. And Azure is a very nice platform that facilitates development of such scalable analytical solutions. So thank you very much. I think I managed to fit in 5 minutes.